relay feedback experiment for the red team. The red team is composed of Chris, and Clay, and our system is the filter wash station with both valves open. Today we're going to talk about first, go over a brief system overview. We're going to look at the SSOC, which was found in past experiments. Then look at relay feedback theory. Then finish with looking at results and conclusions. This is a schematic of the filter wash system. The flow rate controller receives signal from the computer and sends it to the actuator, where it makes a decision as to the input percentage of the pump, which then sends the flow, and the flow rate transmitter records that and sends it back to the computer. For our experiment, both of the valves are open, so the flow was sent to all three filter washing stations. This is the block diagram for our system. The input or manipulated variable was measured in motor power percentage, which is put into the filter wash pump system, which then the output comes out of that, or the control variable, which in our case was wash water flow, which was in pounds per minute. The steady state operating curve was found in past experiments, and we chose the linear operating range, which was from 50 to 100%. To run experiments, we broke it down into three pieces, which one was from 50 to 67%, 67 to 84, and 84 to 100%. The slope of the linear operating range is 0.1 pounds per minute per percent. Picking parameters for the relay feedback, I had to run between 50 to 100% because if you focus in on one of the three parts, you can't even see the output oscillating. So I stayed at that range. The ceiling was 1/4 down from the top of the operating range, and the floor was 1/4 up from the bottom. So that's where those came from. The set point value represents the midpoint percentage, the output at that percentage on the SSOC, which was 15 pounds per minute approximately. And the controller gain was just supposed to be some big number, so just held the 9 yeah. This was the figure that came from entering those parameters in the relay feedback system or experiment. The green line represents the input percentage, which oscillates between the ceiling and floor. That height is the change in M. The period is the time it takes to do one cycle, which is T. T1, little t, is the difference between the height, the difference between the midpoint of the ceiling and the peak of the red line, which is the output, which is in pounds per minute. And as the input oscillates between the ceiling and floor, the red line, or the output, also oscillates. The height to the floor of the output is delta C, and the blue line represents that set point value that was set at 15 pounds per minute and remaining constant. In order to have something to compare that data to, I ran another experiment at leaving the ceiling at 100% and the floor at 50%, so the input range oscillated higher and lower, but the red line was easier to see data because it bigger range to move in. To get to the results for this lab, 3 different calculations were used. The ultimate frequency was just 1 over the average period. The amplitude ratio was delta C, which is the height of the output, divided by delta M, which was the height of the input. And the ultimate gain was 4 times delta M over 5 times delta C. Using those formulas, these results were gained. Trial 1 represents the first plot, and trial 2 was the other one, the higher ceiling. Delta C and delta M varied between the two because the ceiling and floor were different, but in proportion they were still the same because the amplitude ratio remained pretty much constant. The ultimate frequency and ultimate gain also were within reason within both trials. So in closing, I compared our ultimate frequency and ultimate gain with the results they got from the Bode plot. So my ultimate frequency came out as 0.40 plus or minus 0.02 hertz, and from the Bodie plot they got 0.60 plus or minus 0.19 hertz, which is still within the margin of error, so those tend to agree. The ultimate gain was right dead on in both of them, but the Bodie plots seem to have higher degree of uncertainty, but I don't know what that's why. But so in closing, the relay feedback results tended to agree with the Bodie plot results that my teammates found with the frequency response experiment.